So, our last section in chapter 3 is all about like the mathematics of finance. So there are some things in our calculator, and we are going to use some of this, but also some of these things I'm going to expect to be able to see you solving these algebraically by hand. So yes, there are apps on our calculator that we can do, but I also want to know that you can solve an equation like this by hand. So the very first thing, there's some formulas that you're going to need. First formula is our compound interest formula, and this is for annual compound interest. And it says A equals P times 1 plus R to the T power. So that is a really basic, straightforward formula. It looks really similar to our population growth one, maybe a few different letters, but here's what everything stands for. The A stands for the amount in your account. So if you were to call up the bank and say, how much money do I currently have? That's the number that they're going to give you. The P stands for the principal, which is really how much money you are putting in to start that account. So I'm going to say the money originally put in. Normally we call that our initial value. That's the initial amount we put in. The R is going to be our interest rate. We are doing 1 plus that rate because I want to keep a full 100% of my money. Plus, I want to earn interest on that money. And then the T is going to stand for time in years. Now, when banks first started with these compound interest, when they started paying interest for these, they assumed this formula right here specifically, assume that you had a lump sum of money, you're putting it into your account and you're letting it sit there and you're not going to touch it for like 10 years or however long. So you're not going to, like your normal checking account where you put money in, take money out, put money. So it's not that. It's one where you put it in and you let it sit. They also didn't like to lose money. They didn't like to pay people interest. So they would pay you just interest once a year. So maybe if you put the money in on January 1st, they would wait until December 1st, and then they'd pay you, December 31st, and they'd pay you interest for that entire year. And then you'd have to wait another full year before. That's what they mean by annual interest, that in 1 year they're going to pay you interest once. So example 1 is let's just use that formula. It says you have $500 to invest at 7% interest compounded annually for 6 years. How much money would you have? So I'm just going to plug what I know into that formula, and then I'm honestly going to do the rest of the work on my calculator. I want to know how much money I would have if I had this lump sum of 500. I'm going to do 1 plus my interest rate, change that 7% to a decimal, so I'm going to say 0.07, and I'm going to raise it to the 6th power. On your homework for questions like this, that's honestly all the work that I need you to show. And then you would truly go to your calculator, because if you notice, the only variable I have is that A that's off by itself. So I'm going to go to my calculator and I'm going to type that in. Normally we round to 2 decimal places. I would like you to continue to round to 2 decimal places. Oops, I have to make sure I have that in there. Because we're talking in money, and money normally we go to 2 cents. So, or 2 decimal places, not 2 cents. So I've got 500 times the 1 plus 0.07 to the 6th power. So that would tell me I have $750.37. Okay. Now, banks tried to then start to get more competitive. And so then they'd say, well, this bank's only paying you interest once a year. We might pay you twice a year, or we might pay you interest every single month, or we might pay you interest every single day. We're going to vary how long or how often we pay you interest. If they say that they're paying you 7% compounded monthly, which I believe is our next example, that does not mean that at the end of the month they're giving you 7%, and at the end of the next month they're giving you another 7%. It means that they're going to take that 7% that they would have paid you for the full year and take 1/12 of that 7% and pay that to you at the end of January. And then 1/12 of that 7% at the end of February, so that over the course of a year, it's a total of 7%. here's how that changes our formula. Our formula is going to kind of start out the same. So still the amount in the account equals the original amount you put in times 1 plus. But now we have to take that interest rate and divide it up among how often they're paying you. So I'm going to have that rate divided by this n. And then since they're going to keep recalculating those payments, I have to take n times the number of years. So the only new variable that I'm introducing here is this n. And that n and the one up here are just the number of times interest is paid. In 1 year. So between these two formulas, this one is the one that we're going to use the most often because this one will actually work for that last problem that we just did. If they say compounded annually, which is what that last one just said, that just means they're paying you interest one time, so n would equal 1. And if I take r divided by 1, that would just be r. And 1 times t, that would just be t, so it would give me that other formula. If they said monthly, how many months are in a year? How many months are in? 12. So we'd have to put 12 in for n. They might say like daily. If they say daily, we're going to assume that there's 365 days in a year. I'm trying to think what else. They might say weekly. There are 52 weeks in a year, so they pay us 52 times. The only other ones I can think of is they might say like bi-monthly. They might say quarterly. There's 4 quarters in a year. Bi-monthly can kind of be a little confusing because sometimes businesses mean bi-monthly like every other month, but they also sometimes mean bi-monthly like twice a month. So if you ever see that, make sure you clarify that. But see if you can set up your equation for example 2 here, and then we'll see if we can get the example 2 done before we break for lunch. We might have. All that I changed, oh, it doesn't let me write that one. All that I have to change for example 2 I still have 7%, but it says compounded monthly. It won't let me write right there. Below that 0.07, I should say divided by 12. So the 12 times 6 power. When I type that into my calculator, if you have an older calculator like mine, if you have an older calculator like mine, you have to put that into parentheses. If you have the newer ones where it jumps up to that exponent, then you can do that. And we get 760.05. Okay. Write that down, friends. Here you may go to lunch. Friends at home, we're going to pause, and we'll finish these notes when we come back from lunch in about 30 minutes.